Hey everybody, how's it going? Hope you're having a lovely day. So today I'd like to go over a recall, class 1 recall that the FDA is doing of a glucose monitor from a company that is typically known for their top-notch baby formula. That's a joke, by the way. You shouldn't give that shit to your kids. But in all seriousness, this is an interesting thing to go over because one of the things that I've been doing for many years on this channel is going over the design flaws of the products that I work on professionally, because when you see the same product over and over and over again and you see the same mistakes year after year after year, it really starts to become a pattern of things that you should not be doing. So for instance, putting a 50-volt power line right next to a 1.7-volt data line with no ground pin in between on the corner of the machine with no insulation, where you know that liquid is going to get into the computer, that is going straight to the CPU. Like, these types of things are aggravating, so it's something that I have a bit of an eye for. And a pharmacist sent me this one today, which I think would actually be really fun to take apart one of these devices and take a look for ourselves if anybody happens to have one. This says Abbott recalls the readers used with the Freestyle Libre, Libre 14-day, and Libre 2 Flash glucose monitoring systems for risk of extreme heat or fire. This is a Class 1 recall, the most serious type of recall. Use of these devices may cause serious injury or death. Device use. This is intended to provide continuous monitoring of glucose levels. Now, the part that really gets to be BS here is the reason for the recall. And I just want to be 100% clear here. I am not a professional when it comes to medical devices. I do not work on medical devices. But I can kind of read bullshit when I see it, and you tell me if you think this is unreasonable. Abbott is recalling the Freestyle Libre 14-day, blah, 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 which use rechargeable lithium-ion batteries. May get extremely hot, spark, or catch on fire if not properly stored, charged, or used with its Abbott-provided USB cable and power adapter. This potential for overheating, spark, or fire may occur when charging the reader with non-Abbott adapters or non-Abbott USB cables, combined with misuse of the reader and its components. Examples of misuse include exposure to liquids, damage, and introduction of foreign material into the ports. This is seemingly like this victim-blaming language where it's not really that we designed something improperly, more so you're an idiot and got it wet or smashing it or using it improperly. The part here that really gets me is the next line. This is the part that really set off my bullshit sensor as somebody who works on this stuff for a living. The next line is what really set off my bullshit sensor as somebody who has had to troubleshoot USB charging circuits for a living. Again, to be clear, I do not work on professional medical equipment, but USB is USB, and a good part of my job for the last 10 years has been troubleshooting USB circuits at the component level when they malfunction, whether due to a random chip dying, water, or a customer doing something stupid. The Abbott-provided USB cable and power adapter limit the power provided to safely charge the battery, whereas USB cables and power adapters manufactured by a third party may allow much higher power, increasing the risk of overheating, spark, or fire. Now, what I process when I read that is as follows. Instead of actually having a chip die like a Hydra or a TriStar in an iPhone when you plug in a charger that the phone doesn't like, or a PMIC die like in a Samsung phone when you plug in a charger it doesn't like, in our device, it heats up, burns you, and goes on fire. Because either A, we know how to design these types of devices about as well as we know how to make baby formula, or B, we actually do know how to design a good device but decided to save 2 cents per. There are many devices that you can plug into an aftermarket charger. There are many devices that you could plug into a knockoff bad charger that don't go on fire when you do so. And further, when you're talking about a micro USB device, even if you are using something like a Samsung charger that is made for phones where it could put up to 9 volts, the device has to ask for it. A Samsung cell phone charger like the one that you see on the top over here, this is not going to put out 9 volts in the beginning. What it does is it puts out 5 volts, it communicates with the device, and only after communicating with the device and hearing back that it is good with getting 9 volts will it put out 9 volts. The only way this Samsung S10e charger is putting out 9 volts into a standard USB device that only wants 5 volts is if that device was designed in a horribly non-USB standards compliant way. Similar to USB-C. Again, this is a micro USB. This is not USB-C. But let's say it was USB-C. Even if you're using the cheapest garbage USB-C charger, I have never seen a USB-C charger, no matter how cheap it is, that starts off putting out 20 volts or 9 volts. They all do the same thing. They put out 5 volts, they communicate with the circuit, and only if the circuit requests more power does it put out 9 volts or 20 volts. Further, if we are talking about a charger that just is putting out the 5 volts, that is what this thing is most likely asking for, these chargers don't have the ability to put out more power. If you have a static 5-volt charger, it's just putting out 5 volts. A lot of people have this mistaken idea that the charger is what's choosing the power. The charger is what's putting out more amperage. The charger is saying, I'm going to give you 3 amps. And the device is like, no, please, sir, I'd only like 300 milliamps. You're going to take your 4 amps, sonny boy. That's not how this works. The charger is at 5 volts. Now, the charger being at 5 volts, you're going to have volts times amps equals watts. So the charger sets itself at 5 volts. Once the charger is at 5 volts, the charger does not choose how many watts or how many amps that circuit takes. The resistance of the circuit is going to choose that. So if we went over to an Ohm's law calculator, you can see how this works over here. The circuit is what's going to control how many amps are taken. So let's say I have 5 volts and my resistance is 100 ohms. I'm going to get 0.25 watts. If the resistance of the circuit is set to here, then you're going to get 2.5 watts. If the resistance of the circuit is 1 ohm, 25 watts, and so on and so forth. I can't cram more amps into there. That's just not how that works. I can't do, 10 amps, 30 amps, 800 amps. I have no control over that. The charger is at 5 volts, and if the charger is at 5 volts and the resistance of the circuit is 1 ohm, I'm getting 25 watts. The charger can't say, I want to give out 1,000 amps. It's not a thing. The way you change the amount of current the circuit is taking is by changing the resistance. It is the resistance of the circuit, whatever it is you plugged into the charger, that is going to determine how much power is taken. The charger does not get to choose how many watts come out of it. It just chooses voltage. Once the charger has decided to set itself at this particular voltage, how many watts, how much power actually goes out is completely dependent on the device. So they are placing the blame on the charger for putting out too much power, when in reality, if the charger is putting out too much power, it is the fault of the device, because the device did not communicate the voltage that it wants, or even worse, the device did choose the amount of voltage that it wants, but it actually does require less amperage than the resistance of the circuit is set for. So for some reason, the device just fries itself, which is just a complete and utter failure of engineering, again, on par with their baby formula. With deflection, gaslighting, and blaming the consumer on the level of Apple. If this device actually requires that the charger limit the amperage in some way because it does not have its own current regulation built in, that is a sad, pathetic excuse for a charging circuit in 2023. Again, dare I say it, even Apple knows how to design charging circuits that just work, that will just draw the amount of current that it's actually supposed to draw to charge the battery and have the device power on. Samsung phones do this, Pixels do this, virtually every device that you plug into a USB power source does this, and there is absolutely no excuse for theirs not to do that. But I don't think that that's the case here. I don't think that it's even the case that that's what's going on. I think this is just a really, really bad charging circuit, and they're trying to cover it up by pretending that you're using a bad charger when in fact you probably are not. And we've gone over this with several other devices. This is a video. USB-C charging is not as universal as you think. Here I have an external battery case for a phone. Here I have a smartphone. And here I have a pump for an air mattress that came with a USB-C plug. So I am trying 3 different chargers: a Framework laptop charger, a Google Pixel smartphone charger, and a Samsung S10e phone charger. And each one of these chargers with each one of these devices all had a different result. That being said, none of these chargers, regardless of the mismatch of anything, ever provided more voltage to any of the devices than they were supposed to. They start at 5 volts. The thing that drove me the most nuts when it came to Apple products is not even that they have so many design flaws in their products, but it's that they were constantly getting the people that purchased them gaslit into believing they did something wrong. It's not that you made the cable way too short. It's that, oh, why are you opening and closing your display? It's not that you guys put 50 volts next to 1.7 volts. It's like, oh, you guess, you must be looking at your laptop wrong or something. People always manage to shame themselves or shame others around them when their products fail. And as I say here, my problem with the cult of Apple, don't deny your experience. In this case, this is an attempt, in my opinion, by Abbott to try and deny the reality of the experience of their users. It's not that we designed a product that is either non-standard compliant or has shit voltage regulation. Nope, that has nothing to do with it. It's you. You did something wrong. when, in my opinion, they did not. If you have the Abbott-provided USB cable and power adapter and you are not experiencing the problems listed below, you can continue to use the Abbott-provided reader, USB cable, and power adapter. Stop using this and switch to backup method only if you experience any of the following. The reader appears damaged or cracked, visible swelling, reader gets too hot to hold, the reader is no longer able to hold the charge. For example, it turns off unexpectedly or immediately after charging. You do not have the Abbott-provided USB cable and power adapter. To avoid the potential for battery swelling, leakage, extreme overheating, and/or fire, Abbott recommends the following. Charge the reader battery only by using the Abbott-supplied USB cable and power adapter and charger. Do not expose the reader, power adapter, or yellow USB cable to water or other liquids. Do not place the reader in water or other liquids. And again, they're going over... Avoid getting dirt, blood, bleach, and like... People are not putting the reader in blood. That's not the problem. The problem is you created a device that doesn't work properly. Apple, at the very least, knows how to design a USB circuit. Like, they can kind of design a charging circuit so that it doesn't set the user on fire, which is sadly a high standard in contrast to a company that can't even make baby formula that's not poison. There were 88 reported incidents, 7 of fire, and 1 of injury. 7 fires and 1 injury on this product. And something tells me that there are way less of this particular product out there in the wild than there are Samsung S10s, iPhones, Pixels, everything else. I think it would be really cool to get one of these in the shop to actually look at it, open it up, and see how it behaves with different chargers, both the Abbott charger and third-party chargers. I would absolutely love to have this device on a USB amp meter to see exactly what it does with a normal charger and a knockoff charger and kind of record it in real time. I think it would be fun. I think this would actually be pretty interesting to try to dig into how this failure occurs and whether or not this is them falsely blaming their users or genuinely a crappily designed device that is being put into a medical setting. Last thing I think is incredibly important to get across here, just to really hit the nail on the head. Very often when it comes to medical device repair, you will hear that a lot of the problems are with independents that don't know how to service things, people that are just willy-nilly trying to fix medical equipment as if it's a MacBook, leaving out screws, running jumper wires, and this, that, and the other. In reality, it's not us. We're not the ones causing these problems. Independent repair is not the issue. It's the manufacturer when they decide to pinch pennies so that they have more money left over to create poisonous baby formula and design products that don't have functioning charging circuits. It's not us. It's not us. Again, if you really want to look into why people get injured in a hospital, why people wind up having an issue, this is a great interview that I did with a gentleman at a medical expo, Bill Bassick. It was absolutely lovely working with him, and we have a 34-minute interview here that goes over a lot of the right to repair issues in medical. And again, I'm sure that this gentleman could talk on for hours upon hours upon hours with the breadth of his experience. It's not the independent repair people that are causing these issues. It's usually the manufacturer. That's it for today, and as always, I hope you learned something. I'll see you all in the next video. Bye now.